I'm Mr. Joseph, your chemistry teacher. So, still on mole concept, I'm here to give the correction of the work given in our last class, in our last lecture. I gave you an assignment and I asked you, to solve the assignment. I believe most of us must have solved the assignment. I'll be giving the correction, I'll be doing the correction, taking the correction today. If you got the right answer, congratulations for that. If you didn't get the right answer, I just want you to pay attention and listen attentively so you see reason why you got the wrong answer and you learn. So still a mole concept, we say 1 mole of any substance contains the Avogadro's number of particle and is equal to what? The relative atomic mass or the relative molecular mass of that substance, be it an element or a compound. So from that, we're able to relate what? Mole to mass. But today, based on our calculation, we're going to relate mass to volume and also mole to volume. That's what we call molar volume of gases. That 1 mole of any gas occupy a volume of what? 24 dm at room temperature and pressure. We call it molar volume of gas. 1 mole of any gas, 1 mole of any gas occupy a volume of 24 dm. So 2 moles occupy a volume of 2 times 24. 3 moles occupy 3 times 24. So we'll be solving the question before us. And it goes sodium azide decomposes as shown. So 2 moles of sodium azide decompose to give you 2 moles of sodium and 3 moles of nitrogen. You are now asked which volume of nitrogen measured at room temperature and pressure, that's at RTP, will be produced by the decomposition of 150 grams of sodium azide. So from the equation, you discover that 2 moles of sodium azide react to give what 2 moles of what hydrogen. And 1 mole of any gas occupy a volume of 24 dm cube. So 3 moles of nitrogen as a gas will occupy a volume of 3 times 24 dm cube, which is what? 72 dm cube. So I'm going to use different method, different approach to this particular question. Whichever approach, whichever method is suitable for you, whichever method you are comfortable with, please feel free to use it, because at the end of the day, you still arrive at the same word, at the same answer. So we're going to focus our attention on the reactant and the product that is what? That is required, that is demanded. So we are dealing with what? From the question, you are told which volume of nitrogen measured at room temperature will be produced by decomposition of 150 grams of sodium azide. So we are dealing with what? Sodium azide and nitrogen. Sodium azide and nitrogen. So first we are going to do, we are going to calculate what? The mass of 2 moles of what? Sodium azide. So mass of 2 moles of sodium azide will now be 2 bracket what? 23, which is relative atomic mass of sodium, plus what? 3 bracket 14, which is 3 times 14, which is the relative atomic mass of nitrogen. Decompose this to give you what? 3 times what? 24 dm cube of what? Of nitrogen. And remember, 1 mole of nitrogen occupies a volume of 24 dm cube. So let's calculate the mass of 2 moles of nitrogen, which is 23 plus 3 times 14, then times 2. So the mass of 2 moles of nitrogen is 130 grams of what? Sodium azide. So the mass of 2 moles of sodium azide is 130 grams of sodium azide. Produces what? Decompose to produce 72 dm cube of nitrogen. Now you are now asked which volume of nitrogen will be produced by decomposition of 150. Just simple proportion. So 150 grams decomposes to produce what volume of nitrogen? So you put X. So what you have to do is what? You cross multiply. You cross multiply. You now have what? X now will be equal to what? 150 times what? 72 divided by what? 130. So you now have 150 times 72 divided by 150 times 72 divided by 130, which will now be equal to 83.0 01 Tn cube of what? Of nitrogen. Therefore, the answer is equal to what? The answer is B. 83.0 watt dn cube of nitrogen will be the volume of nitrogen produced by the decomposition of 150 grams of what? Sodium azide. It's as simple as ABC. You can decide to use this method. So that is it. Whichever method is comfortable, but I believe this is the simplest way to approach it. But whichever way is suitable for you, please, you are comfortable, please do that. So for those of you who didn't get it, I think this is the right thing. Just check when you made mistake and correct your mistake, and please, I advise you to solve more questions, solve further questions, solve more advanced questions. So let's go to the second method. I'll wipe off this. Remember, we said that I gave you a formula that relates mass to mole and number of molar mass. Mass to mole and also molar mass. Remember, I gave you that number of mole is equal to what? Mass over what? Molar mass. So first of all, the first thing we're going to do is that we're going to calculate what? The number of moles of what? 150 grams of sodium azide. So number of mole is mass over molar mass. So the mass is what? 150, and the molar mass is the mass of 1 mole of sodium azide. So let's calculate the molar mass. Sodium azide is what? MaN3. So sodium is what? 23 plus what? 3 bracket what? 14, which will now be equal to what? 23 plus 3 bracket 14 is what? 65. That is the molar mass of sodium azide. So number of mass over molar mass, which is 65. So 150 divided by 65, which will be equal to 23, 2.3081 moles. So that is it. So that is the number of moles of what? 150 grams of sodium azide. So from the equation, we'll look at the equation: 2 moles of sodium azide, 2 moles of what? Sodium azide, decomposed to produce what? 3 times 24 dn cube of what? Nitrogen. Therefore, 2.30 moles of sodium azide, which is the number of moles of 150 grams of sodium azide, produce X. So you cross multiply, just cross multiply. So it will now be what? 2.308 times 3 times 24 divided by what? 2. Which will now be equal to what? Times 3 times 24 divided by 2. So it will go to 83 point what? 0 what? dm what? Cube of what? Nitrogen. So we can say that we still arrive at the same answer. So the answer is what? B. So please use any method you are comfortable with. So that was it. So please take the correction and solve as many questions as possible. And feel free to contact me when you are confused, or if you have any challenge, if you have any question, I'm always there for you. I'm always there for you to help you out. Thank you very much.